Hey guys, hi.
Welcome to the live stream by the ML Hub. Here we will, in this lecture, we will discuss memory-based solutions for GATE 2026 paper. Let me know in the chat if we are audible and visible. Then we'll start the session. So everyone who have written the exam, like a lot of congratulations, you have overcome the fear of exam. You went there, you have written the exam. Don't don't worry too much about the result right now, and these solutions like which we will discuss today will not be complete. Obviously we don't have the complete paper with us. We have memory based instances, like we remember some of the questions, so we will solve those questions, and meanwhile you can write the questions in the Discord server or in the chat as well. We will pick those and answer those as well.
Audio, video, all good?
So how was the paper, like those who are watching? How did you feel? What was the difficulty level? Like, we just want to do a quick check. How, according to you, how much difficult was the paper? Like, in which band you will put this paper?
Compared to last 2 years, like
Yeah, compared to last 2 years, because those who have prepared, you might have solved 2024 paper, 2025 paper. Compared to the last 2 years paper, how do you feel? Like, how was the difficulty of this paper? Then we will give our verdict as well, how we felt. Firstly, we want to know from you guys. Medium level, right? So actually, like GATE exam, the difficulty level and the paper itself, that's what we have seen. I have seen in the last 3 years is like slightly they are making the paper better and better. So like GATE 2024 was the first time GATE DA happened, and the paper was on the easier side. Then 2025 they added a lot of new things. In 2026 now in this year you might have seen a lot of new things which they have been asking. And I hope now you guys are happy that we covered so much outside the syllabus, inside the classes, because that might have helped you in answering questions in the exam. In probability, a lot of questions on chi-square distribution, t-distribution came. Although it was outside the boundary of the syllabus, that's what we thought, seeing 2024, 2025 paper. But this year there were at least three problems which I remember. 2 from chi-square distribution and 1 from t-distribution, right? So yep, like they are slightly increasing. They are slightly increasing the band, or
lengthy, we can say.
and also
It's
lengthy.
nice, but like
Right.
the problems that can be that should be single correct were like given as a multi
Correct.
select, but only one option was
Right, right. So you might have felt this. How many of you felt like that this problem, that multiple select questions had only a single correct answer, and you were like confused, like should like I recheck it? So, and they increased the number of MSQs as well. Like this year, I think there were around 18 to 20 MSQ problems, which is really high than like last 2 years. So they are increasing the number of MSQ problems, NAT problems, and overall, actually, like the level of question, even if it still remains the same, the lengthiness of the paper and these type of things makes it slightly on the difficult side as compared to the last year. So yeah, overall rating, the paper was moderate difficulty, and we can expect like cutoff wise almost similar as to last year or slightly lower. Once we have the entire paper, then we can give even better estimates, and like after a week or so the actual paper and the responses will also come live. We will again do another video where we will discuss each and every solution as well. In this video we will discuss as many problems as we remember from the exam. Keep writing in the chat, but normal सारे discuss कर लेंगे. Like we already have a pool of 30 plus problems like that we remember from exam that we have written. So we will discuss those, and meanwhile you keep on writing in the chat as well. We want to make this video like and cover as many problems as possible. So firstly I will start with an aptitude problem. How many of you were able to solve this problem? There was a circle, and now this is what I remember. The labeling might be a little different, but this is what the question was. PQR. So this is the first question that we are discussing from Aptitude. Okay, and it was a 2-mark question as I remember. So here this angle was given as 45 degrees. These two are given as equal, and Yep. And we had to find the area of this shaded region. We had to find the area of this shaded region. And the radius of this circle was given as 10 centimeter or 10 units. So the information given was PR is equal to QR. The radius of this circle is 10 units. And the angle PRQ is given as 45 degrees. And we have to find the shaded area. This was the problem, right? Cool. So how to solve this? The internal angle theorem for any circle says that any chord inside a circle, whatever angle that is subtending, which is 45 degrees in this case, will subtend twice the angle on the center. So this angle has to be twice of what the angle PRQ is. So angle POQ should be twice of the angle PRQ. That will make it 2 into 45 degrees, which is 90 degrees. So this angle has to be 90 degrees. Now from this angle we can get this entire angle, like the inner angle, and hence the inner angle POQ, the inner angle will become 360 minus 90 degree, right, which is 270 degrees. The inner angle will become 270 degree. And from that, if I draw a line on the center, the half of it angle, so the angle POR will become 270 degree upon 2, which is 135 degrees. So far so good. And the radius of the circle is already given, so we know that the length of PO is 10 and the length of OR is also 10. And from this information we can calculate the area of this smaller triangle. Let's call this as triangle 1, let's call this as triangle 2, and they are both the same triangles. Symmetric, it's a symmetric figure because these two lengths are equal. And hence the area of this triangle, the area of triangle POR will become, we know these two sides and we know the angle between them. If you know any two sides and the angle between them in a triangle, you can calculate the area as half into length of the first side times length of the second side times sine of the angle between them, which means half times 10 into 10 into, because both of them are equal to radius, 10 into sine of 135 degree. Sine of 135 degree is sine of 45 degree, which is 1 by root 2, and hence this will become 50 into 1 by root 2, yes, which means 25 root 2. And now this is one triangle's area, we need the entire shaded area, and hence the entire shaded area will become twice of it. It is the area of triangle POR plus QOR. POR plus QOR, that will make it 2 times 25 root 2, which is 50 root 2. So there was an option saying 50 root 2, and that is the correct option here. Yeah, this is actually from class 9, 10th math, and they asked it from a long back concept. And yeah, it's like kind of tricky to solve in exam, but yeah, that they can ask these type of questions in aptitude as well, so be prepared for that. Okay, so this was the first question. Let's do the second one. Okay, I have another aptitude question with me. Just a second. Yep. So question number 2 again from aptitude. If PQRS are whole numbers between 0 and 9, which basically they are digits, and PQ and RS are 2-digit consecutive numbers. So PQ is a number, PQ is a 2-digit number, that's what is given. PQ is a 2-digit number. How? So in the question they mentioned that Q is the units place and P is the, let's say, like second place. Okay, so Q is the units place, P is the 10th place, so PQ becomes a number. And also another number is which is given as RS. RS is another 2-digit number. RS is another 2-digit number. And the information which was given was the square of PQ. PQ is like, don't consider PQ as the product of P and Q. PQ is a number essentially. Like if P is 2 and Q is 3, PQ will become the number 23. Okay, that's what they were saying. So, and they said that PQ square plus RS square is X by P. X by P is a 3-digit number. Now here P, Q, R, S, X and Y are also whole numbers. So P, Q, R, S, X, Y are distinct whole numbers. That's what they said. They all are distinct. And another information which was given in the question was PQ and RS are consecutive. PQ and RS are consecutive. So this is all the information which was given. PQ, RS, X, Y are distinct whole numbers. PQ is a 2-digit number. RS is the next number. For example, if PQ is 18, RS is 19, and so on. And the square of PQ and square of RS, if you add them, you will get a 3-digit number XYP. And all the digits must be different. So here the point is, if PQ is 18, RS cannot be, like RS has to be 19, but P and R cannot be same. And hence the only possible options that you have for PQ and RS are, you can either have PQ as 19 and RS as 20 so that all the digits are different, or you can have 29 and 30, or you can have 39 and 40, and so on. But if you take squares and add for 29, 39, 49, they will not be 3-digit number, they will exceed 3-digit number. So only possible case in which you will get a 3-digit number when you add a square of these two numbers is 19 and 20. And hence PQ has to be 19 and RS has to be 20 in this case. And here you can see all the digits PQ, RS are different. And if you add them, if you add PQ square plus RS square, which means if you add 19 square plus 20 square, you get 761, I guess, right? Which is X, Y, P. So here you can see that X and Y are also different from 7 and 6 are different from 1920, and we get the P again back. One is same as the one here, which means everything is correct. PQ and RS has to be 19 and 20, and in the question they asked to find Y. So Y value will be 6. The digit Y will be 6. So this is the second question from Aptitude. Now let us move to the next problem.
Yeah. Let's move on to the third problem that we have had in Aptitude. So this was, although not a very tough problem, but there was a trick that was mentioned in the problem that eliminates few of the options in order to get the correct answer. So let me know if any values are not like correctly mentioned over here. The problem says you have 5 numbers. You have 5 numbers and all are like from 1, all are from 0 to 20. Mean is given. Mean of these 5 numbers is given as 12, right? Median is also given, which is 18, and single mode is also given, which is 20. This information is given, and the problem, the thing that is asked in the problem is total permutations of all possible values of these 5 numbers. You have to mark that, right? Okay. So yeah, like if you assume that the 5 numbers are there, A, B, C, D and E in this increasing order, it is mentioned that the median is 18, right? So since there are like 5 numbers, so median of odd numbers is the middle one, which is C. So with this information, we can say that C is 18. C is 18, right? And if C is 18, it is mentioned that the mode is given as 20 and it is unique. So all the numbers which are on the right hand side, there cannot be a number which is not equal to 20, because it is given that mode is 20. Mode is the frequency of the highest, like the number which is occurring highest number of times, right? So if D and E are greater than C, and it is given that the mode is 20, 20 is also greater than C, then we do not have other options apart from placing 20 for D and 20 for E. So C would be 18, D would be 20, and E will also be 20. So the numbers will be A, B, 18, 20 and 20. Right? Now what's left? Total possible values of A and B. And how we will calculate? We will calculate using the mean, which is given as 12. Right? So what it says, A plus B plus 18, which is C, plus 20 plus 20 divided by 5 is equal to 12, which is the mean. Correct? With this equation, if we take this 5 on the right hand side, it will give us A plus B plus 20 plus 20, 40, 58 is equal to 60, which will give us A plus B is equal to 2. A plus B is equal to 2. Right? With this linear equation, we can find all possible combinations of A and B such that its sum is equal to 2. Right? And only 3 possible combinations are there, either 0, 2 or 2, 0 or 1, 1. Apart from this, no other combination is possible. And it is mentioned that the only mode which is present is 20. 20 is the single mode. So 1, 1 gets eliminated. 1, 1 is the correct value of A and B. But if 1, 1 would be given as A and B, there exist two modes. 20 as well as 1. Both are occurring 2 times. Right? So this gets eliminated. It's mentioned in the problem that there's only a single mode which is available. So the only possible combinations are 0, 2 and 2, 0. And apart from this, I think the question also mentions that we need to give the total possible combinations without only permutations we need to give.
Yeah, and order doesn't matter.
Order doesn't matter. So only one would be the right answer. Correct? Order doesn't matter. We need to mark the total permutations. Right?
Right.
Okay.
So this is another question from Aptitude which came. I have more Aptitude problems which I'll share. So question number 4 from Aptitude. I don't remember the wording exactly, but this is how it looked like. There were like 4 people, Rohan, Tanya, something and something. Okay, there are 4 people. There are 2 boys and 2 girls. Let me just call them with any name right now. The correct answer was Tanya, as far as I remember. So let me explain what the question was. So they said there are two guys from 4th class and there are 2 people from 5th class. Okay, this is another Aptitude question, 2-mark question. So 2 people from 4th class are let's say P and Q, and let me frame it this way. Let me make it better. I don't remember the names. If you remember the name, you can write them in the chat. So from 5th class, the names are, let's say, P and Q, and from 4th class, let's say the names are S and T. And T was definitely, the name T was Tanya. That's why, because this was the answer, that's why I remember this name. And it was given that S is a boy, and T is a girl, P is a boy, and Q is a girl. This was given. Okay, so this is information is given, and they said that these four people play exactly 3 chess games. 3 chess games. And there were a few conditions which are given. First condition which was given was any player who loses does not participate in the tournament anymore. After that, second condition that was given was first match was the only match in which people of same class participated. In the rest 2 games, different class people participated. Another condition given was 2 boys in 2 match, boys were winner. In 2 matches, the boys were winner, and in 1 match, a girl was winner. I think these were the conditions that were given. Okay, and also the another condition that was given was, I think 2025. Like there was some condition which made sure that the first game
played from the same class.
Yeah, that is there.
Okay.
So, okay. So the idea was like this P had to play with Q in the first game. So they both belong to 5th class. And here P will win the match because P is a boy. We want 2 matches to be won by boys. So P will go to the next round, and now P will play with this boy S, which is from 4th class and 5th class, which satisfies the condition. And here again P will win because we want again a boy to win. And the third match will be between P and T because that's the only option left. Because Q and S already have lost the game, so they cannot play again. So the match will be between P and T, and here T will win. Here T will win because we want one girl to win. So this match is also between a 4th and a 5th class student. Actually, yes, these were the conditions, and this is the only possible configurations in which this can happen. The question was, who among the following did not lose any match? Who did not lose any match? So here if you see, P actually won 2 games but lost the last match. The only player who did not lose any match was T, which was Tanya in this case. Tanya or Tanvi, whatever, okay? Yeah. So who did not lose any match is Tanvi. So it was T or Tanya or Tanvi, whatever name was given in the question, okay? Rishi, Tanvi, Pavan and Shruti, okay? So you can swap with the correct names as well, okay, if you want. Okay, let's move to the next problem.
Alright. Problem number
5.
5th. Okay. Yeah, this problem was from English. A sentence was given to you, and we need to fill, like 3 blanks were given. We need to fill these 3 blanks. So, what I remember the sentence was, my friend and I parted first blank. The room or door, I'm not sure, like you can confirm in the chat. Room or door. Second blank. The cabin that I had rented. The third blank, that night. The night, right? And it was like options were given, and the only option that was fitting these 3 blanks, blank 1, blank 2 and blank 3, was at, off and for. At, off and for. My friend and I parted at the room of the cabin that I had rented for the night. This was not a very difficult problem, but yeah, this was the, like these were the 3 words that were fitting the 3 blanks, right? Okay. Yeah, then we had one more aptitude problem, and this was like some parts were given. Different parts of a puzzle was given, and you were asked, if you aggregate these parts, what picture will exactly can be formed using these parts, right? And 4 options were given: P, Q, R and S. So among these four options, the one which is option P, which was like looking like when you aggregate all the four parts of the puzzle and like make a single image, that will somewhat look like a perfect duck. So out of these four options, P, Q, R and S, only option P was like a perfectly looking duck sort of image. So I think this should be the right answer. A perfectly looking duck, which was like, I remember it was option P. Good looking duck like figure, duck like image. Right? So that P should be the right answer. A one with like this sort of image, a head and a beak and so on. Something like that. It's like it's like difficult to remember all the four parts of the puzzle and then like have the correct one. Yeah, but P was the most appropriate one.
Correct. So we want to just give you just like what the correct answer looked like. Yeah, P was the correct one.
Okay.
Cool. And similarly, like there were another problems. There was another aptitude problem from question number 7, I can say. So there is a 3-digit number XYZ, such that the product XYZ are the digits of the number, like units place, decimal place, and the third place. So the product of XYZ is given as, product of these 3 digits is given as 70. We need to find the sum of these 3 digits. So the constraint here is these 3 are digits, which means they are integers. So we can find the prime factorization of 70. If we find the prime factorization of 70, we will get 2, 35, 5, 7, 7, 1. So 70 is nothing but 2 into 5 into 7. The only possible combination is 257 or some other combination of 257. So that number can be either 257, 527 or anything. But what they asked was, they asked sum of digits. So it was a 1-mark question, very simple problem. So what is the sum of digits? In this case, x plus y plus z is 7 plus 5 plus 2, 14. Okay? And
Was right.
I think this was the aptitude question that we had.
Okay. So I remember one more, and it was not a very difficult problem. It says x is given as n to the power log m base 10 and y is given as m to the power log n base 10, and like options were like what, like how x and y relate to each other, right? So it's simple. If you remember the property of the log, it is like you can replace these two numbers, or if you do not remember, you can take log both the sides. It will evaluate as same. So if you take log for this one, log at both sides, it will be log x is equal to, this power will come down. We can take log of base 10. So log n base, it's log n base 10 times the power, which is log m base 10. And similarly for the second equation, again take log both sides, it will give you log y base 10 as log m base 10 times log n base 10, because the power is log n base 10, it will come here and this will be inside the log. Okay, so directly you can say that both are equal. So the option which says x is equal to y was right. This was the right answer. Okay, it was an easy problem. Do you remember further?
No, and I remember one more English problem. It had 4 words, but we don't remember the words right now, and we don't remember the answer also. We didn't know the meaning of those words. So there was one more English problem which had 4 words, ratio and proportion. So I think first 2 were synonyms, and we need to find the synonym of the third word, something like that. If you remember those words, you can write in the chat, and then we'll write that as well. So 2 more aptitude problems are missing. If you remember those 2 aptitude problems, you can ping us in the chat or on the Discord server. We will add them here. Meanwhile, we can move to the subject problems as well. So these are the 8 aptitude problems with their correct answers that we know. Okay, so I have 2 problems from linear algebra. They were like a passage type of question. Okay, so let's do linear algebra question. So, okay, question number 9. This is I'm taking from linear algebra. So it was given that, yep. So there is a matrix In minus 1 by n times 1 times 1 transpose. So it is an n cross n matrix. How? Because 1 was a unit vector. 1 was a vector actually, not a unit vector. It was a vector containing all ones. N cross 1 vector containing all ones. That's what was given. This was the 1 vector. Okay. And we need to find some properties of this matrix. This matrix was called the matrix M. So there were 2 questions. In the first question, they asked, what is M square equal to? So the 4 options were M and then I, then 1 minus M square, something like that. Okay. So in terms of M, what is M square? First question was this. And the second question here was, what is the maximum possible value of W transpose M W for any vector W in Rn such that norm of W vector is 1. So this is standard Rayleigh quotient. If you divide by norm of W square, you will get the Rayleigh quotient. We have to find the maximum possible value of Rayleigh quotient. We know that Rayleigh quotient gets maximized, and the Rayleigh quotient gets maximized if you take the vector W as the principal eigenvector of that particular matrix M, and the maximum value itself is equal to the maximum eigenvalue. So here we had to find the maximum eigenvalue of matrix M, and here we had to find what M square is equal to. Right? So M square, if you solve, like if you just multiply these 2 matrices together, you will get M square as M again. So this answer was M square is M, and here the maximum eigenvalue, like here the eigenvalue is either, like it's a projection matrix. If M square is M is a projection matrix. For a projection matrix, the eigenvalues are either 1 or 0, and the maximum possible eigenvalue which matrix M can have is 1 only. Okay, and hence the maximum of W transpose MW was 1. So these 2 were the questions. The answer of one was M and the second was 1. Okay, if like these were the questions and these were the answers. So this is question number 9 and 10 from linear algebra. And here in the second question, actually there was some information missing. Once the question comes back, I'll re-verify, but there might be a scope for bonus here. The mistake was they did not give the minimum possible value of n in this problem. Okay, so if n is 1, if you take n as 1, then this matrix becomes the 0 matrix. In that case, 1 will not be an eigenvalue of the 0 matrix. Okay, so in that case that will be a problem, and hence only if n is greater than 1, then these 2 options are correct, like M, and for the second question the answer was 1. So there might be some information missing. We will re-verify once the exact question comes, but whole in all, like this was the idea, like these 2 are the problems from linear algebra.
Okay. So I remember a problem from tree traversal which says the pre-order and in-order traversal were given, and in the option, like it was a multiple select question, more than 1 options were right, and among these options, one was also the post-order traversal of that binary tree. Okay, so the pre-order was pre and in order was given, and if you can like draw the entire tree using its pre-order and in-order traversal, you can easily solve that problem. Pre-order was P, Q, then S, E, R, F and G. And in order traversal was S, Q, E, then P, F, R and G. And among the four options, the one option was, is P the root of the tree? The answer is yes. If it is the first node in the pre-order, it will always be the root. So that option was correct. P is the root. P is the root node. That option was right. Only two options were correct out of four options. First correct option was P is the root, and second correct option was the post order traversal of this tree. That you can easily evaluate after drawing the entire BST. Okay, so yeah, we have seen these sort of problems in class. The idea is to pre-order traversal is first root, then left tree, then right tree, and for in order it's left tree, then root, then the right tree. So we'll do the same. Seeing the pre-order, we know that the root node is P. Seeing the pre-order, we know the root node is P. So this is the root. Everything towards the left in the in-order traversal would be the left-hand side of the tree. Everything towards the right-hand side of, in the in-order traversal, right-hand side of P would be the right-hand side nodes of the tree. Okay. So tree starts from P. Some nodes on left, some nodes on right. S, Q and E will be on the left hand side, and F, R and G will be on the right hand side. Among these S, Q and E, the first which is present in the pre-order traversal would be the root, which is Q, right? And similarly, among F, R and G, the first node in the pre-order will be the root of the right hand side. It becomes R. Okay, and similarly, if R is marked, we can mark that R in the in-order traversal. Towards the left will be the left hand side of the tree, towards the right will be the right hand side of the tree. So it will be F and G over here. And similarly for Q, S would be left and E would be right. So if this pre-order and in-order traversal is correct, to an extent what I remember, this will be the tree. And if you form the tree, post-order traversal is not difficult to identify. So post-order, the order is for post-order, the order will be left side, then right side, then finally the root. Okay, so we'll start the traversal from here. We skip the first node that the first node that will get traversed will be S. Start with S, then root will skip, then right hand side E. After that, if left hand side and left side, all the nodes in the left hand side of a specific node is traversed and all the nodes on the right hand side of the tree is traversed, it's time to traverse the root. Q will get traversed, then we'll go back to P, R, F. The next will be F, then G, R, since F and G are already traversed, and finally P, R and P. This was the correct post-order traversal given in the option. Two options are right, post-order and P is the root node. Okay, two more options were there. I think one option was they have interchanged the right hand side and the left hand side of R, and one option was
we have the options
node Q. Okay. Yeah, this was incorrect. Left hand side of R is G. No, it's not. It's the right hand side. And node Q has only one child, which is also incorrect. Node Q has two children S and E. So only correct options were P is the root and the post order traversal that was Q. It was not a very difficult problem. Yeah.
Okay. So this was question number 11, and let's move to the next one. So we have the aptitude question. Someone wrote that in the chat. So I'll just write that for completeness here. So the question was verbosity is to brevity, then insolence is to what? And the options were respect and wealth, solace and innocence. So if you see the dictionary meaning of these words, verbosity is using too many words to explain something. Brevity is using too few words to explain something, which means they are antonyms of each other. So we have to find the antonym of insolence. Okay. Now insolence means being rude. Okay, rude or disrespectful. So what is the opposite of being disrespectful? Giving respect. And hence the correct option here is option A. Okay, and next there was a limit problem. So question number 13 is like there was a question limit and then limit x tends to infinity. Correct me if the equation which I am writing here is incorrect. Then e to the power minus n n to the power x upon x factorial. Is it? What was it?
A summation was also there. It's n to the power k divided by k factorial.
Okay, yeah. And k was going from 0 to infinity. Right. And here we will have limit n tends to infinity in that case. Okay, write in the chat if this is incorrect, but this is correct, I think. Limit n tends to infinity. So here e to the power minus n, which was inside, does not belong to the summation. You can take it out and you can write it as limit n tends to infinity e to the power minus n times summation k is equal to 0 to infinity n to the power k upon n factorial, and this n to the power k upon k factorial. So n to the power k upon k factorial is the expansion of e to the power n. So you can directly write it as e to the power n. And there is another way of solving it as well, by mimicking it as a Poisson distribution, but that will also give you the same answer, okay? But this is the way easier method. So summation of k equal to 0 to infinity n to the power k upon k factorial is the expansion of e to the power n. Basic expansion, like you can do it using Taylor series, or you should just remember it, okay? So it is nothing but e to the power limit n tends to infinity e to the power minus n into e to the power n, which is 1. This was nothing but 1, okay? So limit had nothing to do with. Cool, so this was the question from limit. So we already have 9 out of 10 aptitude question. If any of you remembers the last aptitude question, write that as well, so that we will finish all the 10 aptitude problems also. Cool. Meanwhile, let us solve the next problem.
Yeah. So whoever watched the lectures of Python and attempted the test, this question was straight away from the test. It was whether lists in Python are mutable or immutable when a default parameter is also given as an empty list.
I heard from Srinivas sir, like there were multiple problems in the test series, even in the full syllabus tests in Python, which had this question. And actually, like 2 to 3 problems in Python were on this concept, like list, mutability of list, and list comprehension.
Yes. So the problem was, a function was given, and I don't remember the name of the function. You can assume that first parameter was a number, and second was a list with a default parameter passed as an empty list, right? And in this list, which is the second parameter with a default value as empty list, this value is appended. List dot append well, and this list is returned. So we have seen multiple like problems just on this concept. if the second parameter which is list is not passed, by default it will allocate an empty list to it. By default it will take it. This is how the default arguments work. Okay, and now this function is called and with value say 1, just by 1. If this function is called with only a single parameter, the value is 1. By default, what will be the value of list? It will be an empty list. Either you pass a list as a second argument. If you don't, then it will take empty list for the first function call. Only for the first function call. What it will do? It will return a list. With value as 1. Then again this function was called. I think there was print as well. There was a print outside it. Then again a print. This function is called with value 2. In the second call, they haven't passed the second argument, which is the list. So the common mistake that many students commit over here is they assume that even in the second call the list will be empty, which is not. For the second attempt, for the second call of this function, the value of the list will be this. Why? Because lists are mutable. It will define an empty list only for the first call. If it is not passed, again if you call the function and you skip the second argument, it will take list as this, not as empty list. So what it will return? It will return list with value as 1 and 2 appended. It will append 2 in this list. So the second print will not just 2, this is incorrect, and this option was also present. This option was also given, which is incorrect. So this, it will print this. And now if you call this again, third time also it was called fn with value 3 and with an empty list. Even if you pass the second argument as empty list, it will consider it as a new list. Either you can pass an empty list or a non-empty list. It will only take the default one if you miss the second argument. This will give you 3. This will return 3. So the right answer was 1, 1, 2 and 3. This was the right answer. So how many of you marked it correctly? Tell me in the chat. How many of you marked it correctly? Okay, shall we move to the next one?
Yeah. So let's move to the next question. Question number 15. So very easy question. Summation I is equal to 0 to infinity. Summation j is equal to 1 to infinity. Remember here j was from 1 to infinity, I was from 0 to infinity in the problem. Okay. Again correct us in the chat if we are wrong here. 2 to the power minus I, 3 to the power minus j. This is what we had to calculate. So it was a very easy problem. 2 to the power minus I doesn't matter, like it is independent of j. So you can take it out. So we can write it as I is equal to 0 to infinity, 2 to the power minus I times summation j is equal to 1 to infinity, 3 to the power minus j. Now summation of 3 to the power minus j will become I is equal to 0 to infinity, 2 to the power minus I times, it is a gp. So it will become 1 by 3 plus 1 by 3 square up till infinity. So a is 1 by 3, r is 1 by 3. It is an infinite gp. Sum of infinite gp is a upon 1 minus r. So we will write 2 to the power minus I times a upon 1 minus r. So it will become summation of I is equal to 0 to infinity 2 to the power minus I times 1 by 3 upon 2 by 3, which is 1 by 2. Now here this is another infinite gp. 1 by 2 can come out, so it will become 1 by 2 times this gp is 1 plus 1 by 2 plus so on up till infinity. Here a is 1 and r is 1 by 2. Again then sum is a upon 1 minus r. So it will become half into a upon 1 minus r, which is 1 minus half. So it is half upon half, which is 1. So this sum was 1. The correct answer here was 1. Moving on to the next problem. Next problem is question number 16. So this is from probability, 2-mark question. So someone asked this in the chat कि Bernoulli or normal वाला कैसे होगा? So if again correct me if the question is incorrect, but yeah, as far as I remember the question was x was a random variable which followed Bernoulli distribution with parameter p as 0.3 and y was a normal distribution with parameters mean as 0 and variance as 100, and we had to find the variance of 2 times x minus 1 times y, 2x minus 1 times y. This is what they asked, and there were 4 options. So it is like it was an MCQ single correct question. Okay. Okay, Aman. So how will we solve this? So what is variance of this variable? Variance of this variable, we can write it as variance of 2xy minus y. So variance of any variable is expected value of 2xy minus y whole square minus expected value of 2xy minus y whole square. Variance of x is expected value of x square minus expected value of x whole square, right? Now we can calculate everything based on x and y. So since x is a Bernoulli random variable, expected value of x is p is 0.3, and variance of x is p into q, which is 0.3 into 0.7, which is 0.21, and variance of x is expected value of x square minus expected value of x whole square, which means from here you can write expected value of x square as 0.21 plus expected value of x whole square, which is 0.21 plus 0.09, which will become 0.3. Similarly, expected value of y is 0 because the mean of normal distribution is 0, is given as 0, and variance of y is given as 100, which is expected value of y square minus expected value of y whole square. Now expected value of y is 0, and hence expected value of y square will become 100. Cool. Now based on these values you can directly plug it, and this will become now, and here x and y were given as independent. X and y were given as independent. Very important thing that was given in the question. So if x and y are independent, expected value of x plus y is anyway expected value of x plus expected value of y in any case. If x and y are independent, variance of x plus y is also variance of x plus variance of y, one thing. And also another thing, expected value of x into y is expected value of x into expected value of y if x and y are independent. Okay, all the 3 properties will satisfy. So you can solve it directly using variance also, or since I have already done this, let's solve it using this way. So it will become expected value of, if I open this whole square, it will become 4x square y square plus expected value of y square minus 4 times expected value of xy square, and here we will have minus expected value of 2. Okay, so let me write it this way: 2 times expected value of xy minus expected value of y whole square. So now we need to calculate these things to solve this problem. Okay, so expected value of x into y will become expected value of x into expected value of y because they are independent, and expected value of y is 0, so this will become 0. Expected value of y, this will become 0. Now we just need to calculate these three values. E of y square we already know. E of x into y, this will become expected value of x into expected value of y square, that also we already know. And this will become, so this will become 4 times expected value of x square into y square, so which is 0.3 into 100, 4 into 0.3 into 100 plus expected value of y square is 100 minus 4 into 0.3 into 100. So this will cancel and we will just get 100 as the answer. So the answer was 100. Okay, let's move to the next problem.
Again, the next problem, we have solved similar problem in GDMT2. The problem says that recursion was given to you. A recursion was given. I think they asked total number of like stack activations in this problem. Let's call the function as stack with value n, and the base condition or the terminal condition of the recursion was given as if n is less than equal to 0, return return 1 or 0, I'm not sure. It was the terminal condition of the recursion. Else return stack n minus 1 plus stack n minus 2. Every function call, there were two recursive calls. There were two recursive calls in every function call, right? And they asked total number of stack activations, count of stack activations. And what is the meaning of total number of stack activations? It is how many times this function, there will be some memory that allocated in the stack memory for this function. How many times there will be a memory block that should be allocated for this function call, including the first one, including the first function call which was made with value as 4. Stack 4 was called. Including this, how many times a memory will be allocated in the stack memory? It is what the total number of stack activations is, right? We have seen exactly the same problem. Another variation of this problem can be total, the maximum stack depth at any given point of time. How many recursive calls are present which are active in the stack? But this was not asked. It's like another variation of a similar sort of problems. Okay, so now there are two ways to do it, but like I already mentioned it earlier, if a complex recursion is given in the function, if more than one times the function is called again, in that case always go with forming the branches. You start with 4. If n is 4, it won't hit the base condition. It will make two function calls, n minus 1 and n minus 2. So it will call, first will be for 3, right? N minus 2 is also pending. You can we can have it later, but in 4 the first function call would be stack of n minus 1. From 3 it will be again n minus 1, which is 2. From 2 it will be 1. From 1 it will be 0. If n is 0, it hits the base condition, it will return. No further function calls will be made if the value of n becomes 0 at any instant of time, right? So if we are done with this, the first function call when n was 1, it's time for stack n minus 2 to call the same function with the value n minus 2. In this case, the second function call that will be made from the node 1 would be with value minus 1, which is 1 minus 2, which is minus 1. And again it's less than equal to 0, it will hit the base condition. Here the stack ends for this node, And similarly you can complete the entire tree. The right hand side of 2 would be 1. Again, if it is 1, we have already seen it, 1 will make two function calls. The first will be for 0, the second will be for minus 1. For 0, for minus 1. Right? Similarly, the left hand side of 3 is done. It's time to go towards the right hand side, or the second function call when n was 3. The first function call with n minus 1, the second will be with value n minus 2. So 3 minus 2 would be 1. We have seen what we need to do if the function is called with value as 1. Two function calls, 0 and minus 1. 0, minus 1. And similarly, you can have the right hand side 4, the left hand side will be n minus 1, right hand side would be n minus 2. It will call for 2. And for 2, we have already mimicked the behavior. It will call 1. I think it won't be 1, it's 1 and 0. for 2 the left, if the left side is 1, the second would be 0. Here it will end. Yeah, for 2 it will be 1, 0. For 1 it's 0 and minus 1. Right? So what are the terminal conditions? Here the recursion terminates, here the depth terminates, here it will end, here it will end, this, and this. And we need to count the total number of nodes in the tree. Every node represents a new function call of the function stack. Correct? So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is the right answer of this problem. Like if they've asked what will be the maximum recursion depth, in that case you will again form the exactly same tree. You just need to provide the depth, maximum depth of the recursion, which is 1, 2, 3, 4 and 5. But like total number of function calls was asked, so the correct answer would be 15. Right? Okay, let's move on to the next one.
So someone said that the last aptitude problem was number of bijections. I think it was not in aptitude section. The number of bijections was in technical section itself. So still we are leaving, like we don't remember the one aptitude problem. I think that because let me cover the bijection problem anyway. So the problem was what is the number of bijective functions possible? Number of bijections possible from the set 1, 2, 3, 4 onto itself on the same set, such that by bijection functions f, they are calling it f, such that f of n was n. So this, as far as I remember, this question was in technical section. Okay, and how do you calculate it? To create any bijection, what will you do? So any function when you have to calculate, like the domain of this function was given as 1, 2, 3, 4 and range was also 1, 2, 3, 4. It was a bijection, which means range has to be equal to codomain. So every value should have exactly one mapping. And if you apply the function f, let's say you do some mapping. If 1 is mapped to 1, 2 is mapped to 3 and 3 is mapped to 4 and 4 is mapped to 2, let's say. Let us say. Now if you apply the same function again, so for example, what will be f of 2 in this case? So f of 2 is 3 and then again you have to apply the same function f. So f of 3 will become 4. Because f of 3 was defined to be 4, f of 3 will become 4. So this is an incorrect mapping. We already know how to calculate the total number of mappings. Total number of mappings will be like n into 4 into 3 into 2 into 1, 4 factorial, which is 24, but not all of them are correct. We want this condition to satisfy. F of n should be equal to n. So this is not a correct mapping. So how does a correct mapping look like? So let me give you one of the most basic one. So if I map 1 to 1, 2 to 2, 3 to 3 and 4 to 4, then again 1 will map to 1, 2 will again map to 2, 3 will again map to 3 and 4 will again map to 4. So f of n will again become n in this case. So one such bijection is, bijection means the entire function is, you map 1 to 1, 2 to 2, 3 to 3 and 4 to 4. This is one possible bijection. Now there are not a lot of bijections. Let us see. The next possible bijection will be, let us now firstly fix the mapping of 1 to 1. 1 will map to 1, let us fix that. And let's move to the next mapping of 2. 2 let's say now maps to 3. So if 2 is mapping to 3, 3 has to map to 2 again. Because we want f of 2 to be 2. So if 2 is mapping to 3, we want f of 3 to be equal to 2, then only that will happen. So if 2 is mapping to 3, 3 has to map to 2, and in that case 4 has to map with 4, there is no other option left. So if 2 is mapping to 3, this is the only option. And similarly, if 2 is mapping to 4, the only option is 3 will have to map to 3 and 4 will have to map to 2. This is another bijection that will satisfy this constraint. Another bijection is, again, if you fix 1 to 1 and now 2 is also mapped to 2, then you can swap 3, 4 and 4, 3. So these are the 4 bijections in which 1 is mapped to 1. These are the only possible cases. You can see, like, there is nothing else. Next is, let's say now we map 1 to 2. If we are mapping 1 to 2, then 2 has to map to 1. This is fixed, 1 to 2, 2 to 1. And then for 3 and 4 we have two choices. Either they can remain as it is, 3 to 3, 4 to 4, or we can swap them. 1 to 2 is there, so 2 to 1 is there, and then 3 to 4 and 4 to 3. So we have two possible bijections when 1 is mapping to 2. Similarly, we will have two possible bijections when 1 is mapping to 3, and similarly we will have two possible bijections when 1 is mapping to 4 by symmetry. So total number of bijections will be 4 plus 2 plus 2 plus 2, which is 10. You can enumerate all of them. So the total number of bijection functions will be 10. There are 10 bijection functions which satisfy the property that f of n will be equal to n for any value of n. Okay, only 10. Again, this question was in technical section only, but yeah, cool. So if anyone remembers the last aptitude problem, let us know again. Moving on to the next problem, question number 19. So this question was from probability and matrices. Again, this similar question I gave in GDMT 2 involving probability, and almost same problem. There I asked expected value. Here the problem was slightly more trickier actually. Okay. So there was a 5 cross 5 matrix given, and each element of this matrix was a Bernoulli random variable. Each element of this matrix, let's say this is A11, A12, A51, A21, A22, A52, A31, A32, A33, A34, A35, A15 and A25, and so on, A41, A42, A45. This was the matrix. Okay. Oh, sorry. I have to write the last. Oh, let me finish it. So A41, 42, 45, 51, 52, 55. So these are the 25 elements of a matrix. And all these elements are actually independent Bernoulli random variables. That's what they were saying. With P is 0.5. Then the question asked, what is the probability that the second column sum, the sum of elements in the second column is 3, and also the sum of the elements in the third row is also 3. That's what you have to find. So we have to find the probability of sum of elements in the second column to be equal to the sum of all the elements in the third row, and they both being equal to 3. Now here if you see, all these are independent, all the values are independent, but only this one value is dependent. This one value actually comes in the row also and the column also, A32. So we have to firstly condition on A32. If you fix the value of A32, then the problem becomes easier. If you fix the value of A32, then the problem will be what? So let us say, like there are two cases. The first case is A32 is 1, let's say. The first case is the value of A32 is 1. So every Bernoulli random variable can be either 0 or 1, we know. 0 with probability 0.5 and 1 with also probability 0.5 in this case. So let us say A32 is 1. If A32 is 1, what do we need now? We need 2 more ones in the third row and we need 2 more ones in the second column, and they are independent. Now it becomes independent. Otherwise this common element will give you a problem. So you have to fix the value of the common element. Common element, let's say, is 1. In that case, now the condition becomes we just have to find the probability of having 2 ones in the third row, and similarly two ones and 2 zeros. And we have to find and also the other condition which has to satisfy is 2 ones and 2 zeros in second column, and there is an and between them, and they are independent events. All of them are independent events. The total probability will become the product of individual probabilities, which means if A32 is 1, the probability that we seek for is nothing but probability of getting, here in these 4 values I need 2 ones and 2 zeros. In how many ways can I do it? 4. So this value will become 4C2 times 1 by 2 to the power 2, 1 by 2 to the power 2. This is the probability of getting 2 ones and 2 zeros in the second column. And similarly, same will be the probability of getting 2 ones and 2 zeros in the third row. So same will be the probability of getting 1 by 2 square, 1 by 2 square. Same will be the probability of getting 2 ones and 2 zeros in the third row and in the second column. We want both of them to happen. 2 ones in the second column and 2 ones in the third row if A32 is 1. So this is the overall probability of this happening. So what is this value? This value is 6 into 1 by 4 into 1 by 4 whole square. So 6 by 16 whole square. Right? Okay, yes. And similarly, if A32 is 0, I think now I'm doing it correctly. Previously when I solved it, like I did wrong. Like this is the correct way, okay? If A32 is 0, we need now the probability of getting, if this element is 0, we need 3 ones in the 3 ones here and 3 ones here. So 3 ones and 1 zeros in the third row and 3 ones and 1 zeros in the second column. So the probability of that will become 4C3 into 1 by 2 to the power 3 into 1 by 2 ka whole square, because both these probabilities are same. So in that case it will become 4 by 16 whole square. And hence the total probability of the final event is, now this event also happens with probability half, this event also happens with probability half, and hence the overall probability of this happening is half times 6 by 16 whole square plus half times 4 by 16 whole square. Okay, so you can calculate it and this will be the answer. Cool. So this was the question from probability, Bernoulli random variable. Probability questions were slightly better. Okay, this time, like this in this paper, probability questions were on better side. I felt they and again, as you remember questions, keep writing them in the chat. We will add them in the discussion as well. Okay, let's move to the next problem.
Yeah, so the next problem is on DSA. Again, a recursive function is given, and this is the pseudo code. This is not the exact code. This is what I remember. A recursive function is given, but the concept is same. The concept is same, which is the catch is lists are mutable in Python. First parameter is a list, and the second parameter is a variable with default value as 0. Right? L is a list. Base condition: if I exceeds the list, if this is treated as index in this problem, if the index exceeds the list, if I is greater than length of n minus 1, just return. If this is not the case, in that case the base condition is not yet reached, and I is less than, I is from 0 to length of the list minus 1. The function, what it does, if L of I is greater than L of I plus 1, a list is given. The condition is, if this is I, the next index would be I plus 1. So if the ith element present in the list, if the ith element present in the list is greater than the immediate next element, in that case we will swap these two elements. We will swap these two elements and keep on continuing the process. So it says if L of I is greater than L of I minus 1, then swap L of I and L of I plus 1. And again return 1 plus function with L and updated I, incremented I, right? If this is not the case, else was just return L and I plus 1. Increment I and return. Increment I and return. Okay. And the list which was given in the problem, with variable as data, it was list having 5 elements, 5, 3, 4, 1 and 2. So this was the list which is given in the problem, and initially the count was 0. Initially the count was 0. Then a loop was given, an iteration was given for how many times? Total number. The iteration was number of times the elements present in the list. This loop will execute 5 times. It was mentioned as for underscore in the range 0 to length of data, 0 to L minus length of this array minus 1. Okay, and inside that it was count plus is equal to, the function is called with only one argument as data. That's it. And at the end, print count. At the end, print count. So this was the problem. Right? So in a nutshell, the problems like the count, the value of count, if you like after solving it, it will be quite more intuitive to you. In a nutshell, the problem is asking to count total number of inversions or total number of swaps, total number of swap operations that we are having in this list. The catch is in every function call, the same list object is passed, but the next iteration will have the updated values of data, not the initial values which you have started with. Why? Because lists are mutable. Any operation which is made on this object with label as data will impact the immediate next function call. That's it. Okay, so let's see. For the first function call, data will be this 5, 3, 4, 1 and 2. Okay, for the first function call, for the first iteration, it will be 5, 3, 4, 1 and 2. Right? So now we'll get into this recursion, this function call with value of I as the default value. Every time I will start with 0. If not passed, in this case it is not passed, so it will be like 0. Base condition is not triggered, so we are into this if condition. If L of I is greater than L of I minus 1, I is 0. If I is 0, whether 5 is greater than 3, answer is yes, it is. So what it will do, it will swap. It will swap this 5 with 3. After swapping, we'll again make this function call, but we are also incrementing the final value by 1. Then calling the function again with incremented value of I. So for the next function call, 1 plus this function is called, where I initially was 0, but in this case it will be 1. So I will start from here. And we'll ignore the else part. Why? Because if is triggered. Okay. So what it will return? It will return 1. Let me write it here. It will return 1 plus whatever this function call will return. Correct? Okay. So the updated value of L which is being passed in this function will be this 3, 5, 4, 1 and 2, where I is 1. We'll get into this function again. Base condition is checked whether I is greater than length of n minus 1 or not. Answer is no, the I is not yet crossed all the elements present in the list. If condition is checked whether L of I is greater than L of I plus 1. I is now 1. Whether 5 is greater than 4. Answer is yes. Again we will do a swap. It will be 5. This becomes 4. Third element becomes 5. This will be 4. This is returned. So answer 1 will again add up to the final answer. Third time this function is called with incremented value of I. Now I will point to this. I becomes 0, 1, 2. I becomes 2. Okay. Same we'll do again. We'll check the base condition. It won't get triggered if L of I is greater than I plus 1. Every time we are checking the current value, current index value with the immediate next until we see all of them. So 5 is again greater than 1. So they will be swapped. They will be swapped and value of I will be incremented by 1. I becomes 3 now. Again, you can see total number of ones that I am writing over here are total number of swaps that we are performing on this list. If no swap, in that case we are just returning. We are just returning the function with incremented value of I. We are not adding 1 to the final answer. Okay, and finally 5 and 2 will be compared again. If 5 is greater than 2, then we will swap them again. I is incremented to, this becomes I, which is 4, and 1 is added. Okay, that's it. This is the base condition. Here the base condition is reached. If you again call this function with value of I as 5, it increased the total number of the index is out of bound. Basically, this is what the base condition was given in the problem. If I exceeds the length of the list, just return 0, I guess. Return 0. Okay, so the first iteration, this is, we have just completed the first iteration. The value of this function will be 1 plus 1 plus 1 plus 1, which is 4 for first iteration. Right? And after first iteration, what will be the value of the list or the data? The value of list after the first iteration is completed will be 3, 4, 1, 2 and 5. 3, 4, 1, 2 and 5. Can you see a pattern over here? What the function is doing? The function is just picking the largest element and trying to make number of swaps in such a way that the highest element in the first iteration goes towards the end. Highest element goes towards the end. Similar to what we do in bubble sort. We try to find it, the highest element, and swap it with the consecutive ones till the highest element goes towards the end. So this is what the value of data after first iteration. Right? Similarly for second iteration, and we need to run this iteration like 5 times. For the second iteration, data will be this. The function is called again with value of data as 3, 4, 1, 2 and 5. Okay, so let's see for the second iteration. For second iteration, we are starting with 3, 4, 1, 2 and 5. So if the first iteration is clear to you, I will be quick in solving the value that is returned for the second iteration. For second iteration. Okay, we'll start again with I as 0. We'll start from here. Base condition is not yet triggered. Whether 3 is greater than 4, answer is no, else part will execute. If the else part is getting executed, we are not returning any other constant rather than just the function with incremented value of I. This one was absent from the else part. So it won't add up anything to the count. It will just call the function again with value of like I as I plus 1. So we won't do anything here. This becomes I. I becomes 1. Right? Now we will check whether 4 is greater than 1. The answer is yes. It will get into the if part. We have to add 1. First we'll swap. 1 will be here and 1 and 4 will be swapped and 1 will be added. The function will be called with I plus 1. This becomes your I. 2. Again 4 is greater than 2. One more swap. This becomes your I. Is 4 greater than 5? The answer is no. So else part will execute L, comma I plus 1. This becomes I. This becomes I, and it like returns. It hits the base condition. It hits the base condition. The total number of swaps that we did for the second iteration were 4 and 1 were swapped and 2 and 4 were swapped. 1 plus 1, which is 2. right? And what will be the list after second iteration? It will be 3, 1, 2, 4 and 5. 3, 1, 2, 4 and 5. And again you can see 4 was the second largest element in the list. 4 was the second largest element in the list. After second iteration, it goes to the second last position. Keeping the sorted order maintained. Keeping the sorted order maintained. And if this is clear, now you can calculate for the remaining iterations, the iteration 3rd, 4th and 5th. For iteration 3, just count the total number of swaps and keep on swapping the elements. Starting with 3, 1, 2, 4 and 5. Is 3 greater than 1? Answer is yes. For third iteration, is 3 greater than 1? Answer is yes. We'll swap. Is 3, 1. 1 will be here, 3 becomes here. Is 3 greater than 2? Yes, again swap. And add 1. And add 1. Right? Is 3 greater than 4? No. So this function will be called and we won't adding anything to the final answer. And 4 and 5 will be compared, we'll do nothing. After third iteration, it becomes 1, 2, 3, 4 and 5. 2. Right? 2 more iterations are there. In the fourth iteration, this will be the array that will start with 1, 2, 3, 4 and 5. But there is this is already sorted. So this the recursion will not get into this if condition where L of I is greater than L of I minus 1. For for any I you can check, this condition won't hold true. So it just keep on going in the else part for fourth iteration and the fifth iteration. So nothing is added to the final count for fourth and fifth iteration since it's already sorted. No swaps, no incrementing the count. Okay, and finally it is whatever this function is returning, we are adding it to the count. Count was started with 0. So if you aggregate all of them, it's 4 plus 2 plus 2. I think 8 is the right answer. Is it clear? Anyone got 8? All right. Next question.
Okay, so there was a question from linear algebra where we were given a rotation matrix, standard rotation matrix. So the question, as I remember, is if M is the matrix cos theta minus sin theta, cos theta. We know that this is the standard rotation matrix by angle theta. It just rotates any vector by theta degrees. Rotation matrix by theta. Okay? And theta is given as 2 pi by 5. And we had to calculate m to the power 2016 in terms of m only again here also. Okay, is m to the power 2016 equal to m, I minus m or so on. So these were the options. So how will we calculate it? It's like you are rotating with by 2 pi by 5 angle 2016 times. So total angle at which you are rotating is what? Total angle will be what? 2 pi by 5, then 2 pi by 5, then 2 pi by 5. M to the power 2016 is like applying that matrix 2016 times. Right? It was 2016 or 2026 I think, right? Because of the year 2026. It must be 2026. Okay. So, okay, let's say it was 2026. So total angle by which we were rotating this particular vector, this particular matrix, when we multiply 2026 times, it will rotate a particular vector by 2 pi by 5 these many times. So total angle will be 2026 times 2 pi by 5, which is 4052 by 5 pi, which is 810 plus 810 full pi rotations. 810 pi plus 2 pi by 5. Now if you rotate any vector by 800 pi degrees, it's like 2 pi into, because this is multiple of 2 pi. One 2 pi rotation means this vector will become same vector again. And this 810 is divisible by 2, so I can write it as 405 into 2 pi also, plus 2 pi by 5. So rotating by this much is nothing, it's like doing nothing. So overall you are just rotating it by 2 pi by 5 only. So when you apply this matrix, it is essentially by rotating by 2 pi by 5 only. So applying this and applying m are same, and hence m to the power 2026 is same as m. This is the classical property of rotation matrix, that's why this was happening. Okay, so this was one question. Another similar question was, it was from probability actually, not this is for linear algebra. Another question was from probability, that also included 2026 the year. Okay, so another question was 22nd question from probability. So the question was, you are taking a sample from 1 2 3 2016 and you take any non-empty set out of it, non-empty set, you pull any non-empty set out of it. What is the probability that product of this set, product of the elements of this set is even? That's what we have to calculate. So first thing is, again here also, again correct me in the chat if I'm wrong, here also the numbers were 1 to 2026 only, sorry. Right? Whatever this number was, okay, like it was some like big large even number, okay, cool. So the idea is how many sets we can create. The probability will be total number of such sets which have a product of even upon total number of sets possible. So how many total subsets we can create of from this set? Total number of subsets will be 2 to the power 2026. But they are saying non-empty. They are saying non-empty subset, which means the empty subset will be removed. So total number of subsets possible is 2 to the power 2026 minus 1. Now the numerator is what? Numerator is the number of such subsets which have a even product, which have a product as even. Now we know that when is the product even of n numbers, when is the product even? For n numbers, the product is even if at least one of them is even. If any one.
Yeah, I think it's connected again.
Okay. So what is the total number of cases in which product is even? When is the product even? When at least one of them is even. And the product is odd if all the numbers are odd. So if I can just subtract all the cases where from all possible cases. So total number of possible cases is 2 to the power 2026 minus 1. From this I will subtract all the cases in which all the numbers are odd only. Which means I am taking subset of odd numbers only. Their product will be odd. So in how many ways I can take just a subset of odd numbers? How many numbers are odd? The numbers which are odd are 1, 3, 5 up till 2025. Which means there are 1, 0, 1, 3 odd numbers. And we have to take a subset out of this. Again a non-empty subset. So the total number of subsets possible here will be 2 to the power 1013 minus 1. I'll subtract these subsets from this and I'll get the subsets in which there is at least one even number present. So minus 1 will cancel, and here you can take 2013 out. So So here you can take 2 to the power 2013 out. So you will get 2 to the power 2013 minus 1 upon 2 to the power 2026 minus 1. So there was an option which contained exactly this expression, which was the correct option in this case. Okay, cool. So let's move to the next problem now.
there was a problem on concept hierarchies. I do not remember the other ones, but yeah, 3 concept hierarchies were given, and the problem was asking total number of data cubes required to have the aggregated data of these concept hierarchies. One concept hierarchy was like all the hierarchies were similar, just they were representing different types of data. So concept hierarchy 1, concept hierarchy 2, concept hierarchy 3. So we have seen the concept of this concept hierarchy in the warehousing, where you can form, if you have a data, you can have a hierarchical structure of the data in which the top level nodes or the nodes with which the hierarchy is starting are more aggregated sort of nodes, and the more you go down the tree in the hierarchy, the more granularity you are achieving in your data. For instance, the first concept hierarchy was given in the problem was, it was starting with year, then it was month, then it was day. Right? You can see the hierarchical pattern. Year is more like aggregated form of data. Then year can be you can form a tree like structure. From year you can form 12 nodes representing each node representing a month, Jan, Feb, and so on. And from each node you can have days. This is what the idea of concept hierarchy is. Okay, so the problem was asking, and similarly 2 more concept hierarchies were given. Do you remember what was the label of these concept hierarchies? The remaining 2 apart from year, month, and day.
I don't, but yeah, they were similar. They were
all 3 were same.
All 3 were same. Yeah, on the same figures.
Okay, anyone if knows, let us know in the chat. But it won't impact the solution. Alright, so if you were able to solve for anyone, you can multiply or you can do the similar thing for the remaining 2 concept hierarchies in order to get the total number of data cubes required. Okay, for this case, you need 1 data cube just for representing days. Right? We are talking about concept hierarchy 1. You need 1 data cube to represent days. Then when you go above, on a level from lower level to higher level, you need 1 more data cube. You need 1 more data cube to represent the data related to months, aggregated over days, obviously. And again, when you go up in the concept hierarchy, you need 1 data cube for year. And what it will represent, it will aggregate the entire data of these specific years over the months and days. But the catch was, you need 1 more data cube. You need 1 more data cube in order to have the aggregated data of the entire concept hierarchy. This was the catch. This was the catch. So 1 concept hierarchy will need 4 data cubes. 1 concept hierarchy will require 4 data cubes, and 3 different concept hierarchies were given. So the correct answer was 4 to the power 3. And there were different options as well. Options were 2 to the power 3, 4 to the power 3, 2 factorial, and if I remember, the 4th one was 4 factorial. So this is the right answer. Make sense? And yeah, this was the overall idea behind the problem. You need 4 data cubes for 1 concept hierarchy, and there were 3, so 4 to the power 3. Right? Yes, again, similar question was present in the test series of warehousing.
Yeah,
Data cubes on concept hierarchy.
A lot of questions are coming directly from the test series, and that's good. I think students who have practiced our test series and given the GDMTs might have been able to solve a lot of questions. Cool. I think we can move to the next problem. This was question number 23. Let's do question number 24. So there was a question like we found someone commented just commented the last aptitude problem. There is another English problem. So now aptitude problems are done. This is the last or the 10th aptitude problem. Okay. So it's an English problem. If his latest movie or the last movie, something like that, if his latest movie had been successful, some actor, he would have been, this is very important, he would have been able to fund the coming movie. And there were 4 options given. What can be inferred based on this statement? What can be inferred based on this statement? So the correct answer here was, since they are talking about he would have been able to, if his latest movie had been successful, in that case he would have been able to fund the coming movie, which means that his latest movie was not successful. Otherwise we would have not been talking about this, right? So the only statement which can be inferred from this is his latest movie was not successful. Okay. Okay, so let's move to the next problem. So next problem is from linear algebra. Question number 25. Very simple problem. So there was a matrix given which is 1 0 0 0 cos t sin t 0 sin t cos t, and t belongs to minus pi to pi, and gamma 1, gamma 2 and gamma 3 are the eigenvalues of this matrix M, are eigenvalues of matrix M. Then they said that the sum of these eigenvalues, is 1 plus root 2 plus 1. The sum of the eigenvalues of this matrix was given as root 2 plus 1. Then what value of t? What values of t will satisfy this constraint? So we had to solve it. So we know that sum of eigenvalues is nothing but the trace of the matrix, and hence we can say that gamma 1 plus gamma 2 plus gamma 3, or the sum of the eigenvalues is nothing but the trace of the matrix, which is 1 plus 2 cos t, is equal to root 2 plus 1. Plus 1 cancels, so you will get cos t is equal to 1 by root 2. So now in the graph of cos t, where t goes between minus pi and pi, if t goes between minus pi and pi, here pi by 2, here pi by 2, cos graph looks like this. So at how many, or at how, which values it becomes 1 by root 2? It will become 1 by root 2 at exactly two values. This is 1 by root 2, pi by 4 and minus pi by 4. So exactly two values of t will satisfy it, pi by 4 and minus pi by 4. It was an option, like there were 4 options. The correct answer is pi by 4 and minus pi by 4. It is not a set like this. It is just for these two values of t this will happen. Okay, so this was the question on matrices. Let's move to the next problem now.
The most easiest problem of the test was from AI.
Yeah.
In which 4 such algorithms were given. and they asked which of them is not a uninformed search, and the answer was I think options were DFS, correct me if I'm wrong, BFS, iterative deepening, and A star. And obviously A star was the correct answer. Okay. And one more easy problem was given on Minimax. Problem number 27. A tree was given. Starting with max nodes, 3 choices or 3 min nodes. Every min node again at 3 choices. And the values were 3, 6, minus 1, 1, 5, 7, minus 4, minus 3, minus 12. You can correct me if the values are not matching with the values came of the nodes of this minimax in the question. Right? This is the max node. This is the min. And they've given that every player is like playing optimally in order to win the game. What will be the value? What will be the final value of this max? Again, pretty straightforward. We have done plenty of examples like this. Every min node will always choose the best for it, which is the least node, the least option, right? Among all possible choices. For this node, let's call it A, B, C. Node A is a min node. It will choose the minimum of all 3 possibilities, which is minus 1. Minimum of all 3. Right? Then B, minimum of all 3, 1, 5 and 7. And finally C, minus 4, minus 3, minus 12. Right? Their parent is a max node. It will pick the maximum of A, B and C, which is 1. So the right answer of this problem is 1. So from search part, both the problems were very easy. Okay. Next problem.
Okay, very simple problem came from Bayes rule. Those who have watched even like 10 minutes of my Bayes rule lecture.
Yeah, minus 12 minimum. Like even if like 1 second. Yeah, even if minus 12 is minimum, it will choose the maximum, which is 1. It won't impact. Yeah, this is minus 12. Right? Correct.
Yeah, correct.
Thanks.
Yeah, so even if you watch the 10 minutes of naive Bayes class, you would have been able to answer the question. Very simple problem came. So the lot of language was written. The tree, the final naive Bayes tree was something like a random experiment is done, and the probability of a person having like disease, he might have disease or he might not have disease. The probability of someone having a disease was given as 0.3, and the probability of someone not having a disease is 0.7. If someone has a disease, then the probability of them being tested positive, was given as 0.8. And if someone has a disease, the probability of them being tested as negative was given as 0.2. And similarly, if D is no, which means if someone does not have a disease, then the probability of someone being tested positive and negative was 0.1 and 0.9 respectively. And in the question they said that if someone had been tested positive, what is the probability that they actually had a disease, or which means disease was yes. So you have to calculate the probability of disease being yes, given that they were tested positive. So standard name base, base formula, sorry. So this is the route that we took. We want to find the probability of this route. So it will become 0.8 into 0.3 upon 0.8 into 0.3, or the total probability of someone being tested positive, plus 0.7 into 0.1. So 24 upon 24 plus 7 is 24 by 33. So the answer was around 0.77. They had to round it to 2 decimal places. So this was the answer. Moving to the next problem, there was a question from linear algebra. And the question was, a beautiful question. Okay. The question was, if so you are given as S was given as a subspace. S was given as a subspace which contained all vectors. Vectors were of form x1, x2, x3 transpose. So there were 3-dimensional vectors. So they were vectors in R3 such that the norm of the vector was less than 16, less than or equal to 16. Right. So this was the subspace given. And there is another subspace given is, let's say, subspace P. So another subspace P is given, which is any subspace, plane, which was actually given as a plane passing through origin. A plane of 2 dimensions, which is a subspace. It was given like a plane which is a subspace in R3. So plane which is a subspace has to pass through origin, right? So plane of dimension through 2 passing through origin. This is additional information which I am writing. It has to pass through origin. So we just had to calculate the area. We had to calculate the area of P intersection S. So what we had to do here is, so if you see that the norm of the vector has to be less than or equal to 16, so in 3 dimensions it will become a sphere. Norm of the vector is 16 means, let's say here this is 4, like the radius of this sphere will be 4, right? Because the norm of this vector will become 16. Norm square actually, not norm. Norm square was given as 16. X transpose X is norm square. So norm of this vector, like if ith component is 4 and j and k are 0, then the norm of this vector is 4, similarly for j and similarly for k. So and there it will be a sphere lying on these 3 vectors. A sphere in R3 passing through origin. And then they are saying you can take any plane passing through origin. It doesn't matter, right? If you take any plane passing through origin and try to cut this sphere, it will intersect exactly at one circle. The same circle you will get every time. So let us take the xy plane only. Who is stopping us? Even if we take the xy plane and we try to cut this sphere, what we will get? This is the xy plane, and we will get a circle, and the radius of this circle will be 4. That's all. So and hence the area of this P intersection S will be the area of a circle of radius 4, which means pi into 4 square, which is 16 pi. So 16 pi was the correct answer here. This was the area of the intersection of these 2 subspaces. Again, write in the chat if you made this question correct. Any doubts in this question? I think this was an easy problem. Both these problems, like which I discussed right now, are easy problems. Let's move to the next problem then.
A problem was asked on the time complexity, the recurrence relation of quicksort, a specific variation of quicksort. What's mentioned in the problem was array is given and the numbers present in this array are like in random order. Value are randomized, right? And 4 options were given, or 4 recurrences were given. Tn is equal to T of n by 4 plus 3n by 4 plus big of n. T of n is equal to 2Tn by 2 plus big of n. T of n is equal to T of n minus 1 plus big of n, and T was a case where T of n is equal to 1 by n sigma k starting from 0 to n T of k plus T of n minus k minus 1 plus big of n. Right, and you need to mark the correct time complexity recurrence, which recurrence is representing the correct time complexity of the quicksort or the variation of quicksort mentioned in the problem. Okay, so if a single word randomized was not mentioned in the problem, in that case what would be the answer? In that case answer would be option A. In general, more or less, like if you solve this recurrence, all of them, all these recurrences, not all this, I think A and D, both A and D will converge to n log n. Option B is the best case, where the pivot is exactly the middle element. What it is saying the recurrence T of n is equal to 2 times T of n by 2. It is exactly breaking the array into two halves, which is only possible when the pivot is the middle element. This is n by 2, n by 2. This is the best case. Option C is the worst case, which, or you can say the array is already sorted. So like this also won't be the answer. So only option A and option D left. But since it's mentioned that the values are randomized and we are always taking the first element as pivot, even though we are always taking the first element, the values are randomized. So this is equivalent to randomized quicksort. So if you have like read about it, randomized quicksort, then D would be the right answer. Why? Because it is creating a randomness. If you take this array, even though it is mentioned in the problem that the pivot is always the first element, but all numbers are randomized. All numbers are randomized. So this first element in the original array, before it was randomized, the position can be anywhere between 0 to n minus 1. The position of the first element, which is like treated as the first pivot element, it can be anywhere. It can be anywhere, right? So it can be anywhere from 0 to n minus 1, and let's say it is at specific index k. So we need to add the recurrences involving to sort the left hand side of the pivot and the right hand side, which is 0 to k minus 1, T of k, and k to n minus 1, which is n minus k minus 1, right? So right answer was D. Okay, and the correct answer of that cube, was 4 to the power 3. We have already discussed it. You can check out the recording. Total number of data cubes were 4 to the power 3. For every concept hierarchy, we need 4. Okay, so this was problem 29th.
Okay, now let's see some ML problems. This is all I have for probability and linear algebra right now. Again,
they have asked in ML whether naive Bayes is a classifier or a clustering algorithm.
Yeah, I'll come to that question as well. I'll come to that. So now let us move to ML problems. ML was like easiest subject in today's paper. Like all the ML problems were very easy. Okay, mostly like if you know, there were a lot of neural network problems and very simple problems essentially. So yep, let's see. Let's see some ML problems. And if you know more probability and linear algebra problems which we might have missed, write them in the chat. I'll add them as well. So first is the theoretical problem regarding ridge regression. What does ridge regression do? Ridge regularization do, sorry. What is the ridge regularization property? So there were 4 options. First was it increases bias. It increases bias and decreases the variance. Second option was it uses the L1 norm or penalizing. Third option was it is it removes the parameter which have negative values. Removes the weights with negative values. And there was one more option which was very obviously incorrect. I don't remember that option, but yeah, these 3 were the options, and 4th option was also incorrect. The only correct option was it increases bias and reduces variance. Because whenever you add regularization, standard bias variance trade-off, okay, you are essentially increasing the bias in the model and you are decreasing the variance in the model. And it does not use the L1 norm, it uses L2 norm, we know that. And it removes the weights and negative values. Incorrect, it never removes weights. The L1 or lasso regularization, that removes weights, those who have 0 value, there also. Okay, lasso regression removes the weights which have 0 value, not negative value. So no regression actually removes values with negative values. This was also incorrect. So only option correct here was one related to bias and variance. Okay. And similarly, another very simple theoretical question only, which like it was not theoretical question only. It came from model evaluation and validation. Was like there are 1000 points, out of which the first 100 points are used for training set. They are used as the training set. And we are using leave one out cross validation. We are using leave one out cross validation in this. So in leave one out cross validation, what do? We use 1 point for validation and the remaining for testing, and we do it for every point. So how many validation sets will be created? How many train or validation sets will be created? So if we are using 100 points for test training, 100 points are used for test set as the test set, not training set. So if you are using 100 points for testing, we are using the remaining 900 points for training and validation. So 900 points are used for training and validation. Now every time we will do what? We will use 1 point for validation and remaining 899 for training, and we will do this for every possible point, which means the number of such sets we will create is 900. Number of sets of that we will create is 900. In every one of these sets, 1 point will be in validation set and the remaining 899 will be in the training set. Okay, so the correct answer here was 900. Cool. So these 2 were theoretical machine learning problems. Now let's move to the next problem.
So a problem was asked on functional dependencies, and we need to give the total candidate keys just by checking the functional dependencies. A relation is given with 5 attributes. And in this relation, 3 functional dependencies were given: A to BC, CD to E, and E to A. And we've seen plenty of problems similar to this in which the total candidate keys we need to identify given these functional dependencies. A candidate key is a key given the set, you can uniquely identify all the remaining attributes, or like the entire tuple, the set of all attributes. So clearly we can see from these functional dependencies that attribute D is not present on the right hand side of any of these functional dependencies. So attribute D will always be part of any candidate key possible for these functional dependencies. So there were few options which, like I don't remember all the options for this problem, but there were few options in the exam that involved only one attribute, and they were saying whether it's a candidate key or not. So straight away these all these options gets eliminated. So D will always be there, since D is not reachable from any of these. Okay, so let's see. And I think the options are not, like I don't remember the options. You can let me know in the chat about these options. But yeah, CD closure we need to identify whether it's giving all the attributes in order to claim that CD is a candidate key of this relation giving these functional dependencies. So with C and D, you can reach to C, you can reach to D. If C and D are given, you can reach to E. If E is given, we can go to A. And if A, then B is also reachable. So yes, CD is a candidate key given these functional dependencies. And again, there was one more option. I think ED. We can check if ED is given, whether it's a candidate key or not. With E, we can reach E. D is also we have. If we have E, we have A, and from A, B is, yeah, correct. So E, D is also a candidate key. Apart from this, we can check for a few more. AD. If we have A, then we have B and C. If we have B and C, if we have B and C, we do not have, we also have D. If we have D, then we have C, D. From C and D, we can have E. Correct. So AD is also a valid candidate key. So these are the valid candidate keys. So right. So there was an option involving all of them, if I remember correct. That was the right answer. Okay.
Yeah, I think here the options were like this only, like there were sets. So option A contained like the candidate keys are AD, ED and CD. So this one was correct. And then in other options the candidate keys were incorrect, like some other sets were given. So the only possible set of candidate keys was this one or something like that. Cool, but yeah, these are the candidate keys. I hope like everyone marked it correctly. Write in the chat if you have. Let's move to the next problem. Okay, so next problem again from ML, it is from PCA. So this is question number 32. So in this question, PCA is applied on a 1000-dimensional data set. PCA is applied on 1000-dimensional data set, and we bring it down to some 10 yeah, 100-dimensional data set or 10-dimensional data set. It was something like that. It was a very silly and very simple problem actually. So we are bringing 1000-dimensional data set to a 10-dimensional data set, and what we need to calculate, we needed to calculate the angle between, if theta is the angle between the first principal component and the 10th principal component, then what is the value of theta? So one option was theta is less than 90 degree and between 0 degree. One option was theta is 90 degree. One option was theta is between 90 and 180 degree. And one option was theta is greater than 180 degree or something like that. 0 degree. Okay, so these were the options. We know that whenever we do PCA is done on a covariance matrix. Covariance matrix is a symmetric positive semi-definite matrix. Positive semi-definite matrix, and it is symmetric. Symmetric is important. And we know that these principal components are eigenvectors of that symmetric matrix. And eigenvectors of a symmetric matrix are always orthogonal, right? Like the eigenvalues corresponding to different eigenvalues for a symmetric matrix are always orthogonal. You can always find n orthogonal eigenvectors of a symmetric matrix, and we find all the orthogonal or orthonormal eigenvectors only in PCA. In PCA, when we do the eigen decomposition of the matrix X transpose X, which is V lambda V transpose. In V, we are actually writing the eigenvectors. All these eigenvectors are orthonormal. Their norm is 1 and they are orthogonal to each other. And hence, all the first principal component will be orthogonal to the 10th principal component. Actually, first, second, third, fourth, 10th, all of them will be orthogonal only. Their angle will be 90 degrees. So it was like a very simple problem. The answer was 90 degree. Moving on to the next problem. Okay, the next question is from so like a lot of data was given and you can create the confusion matrix on it. Very easy, like, so the confusion matrix looked like this. So actual label xy, and this is the predicted value of label x and y, and the values were 14 and 6. So the sum was 20. There were 20 actual x's, and there were 2 and 8. So 10 total y's, and predicted is 16 x's and 14 y's. And there were 4 options. First option was recall of x is greater than recall of y. Let me write them down. First option was recall of x is greater than recall of y. Second option was precision of x was greater than precision of y. The third option was accuracy of this model is 11 by 15, and the fourth option was accuracy of this model is 14 by 15. 11 by 15 or 11 by
11 by 15.
11 by 15, right?
Yeah, one option was 11 by 15 and one was 14 by 15.
Yeah. So this was the question. So what is the accuracy of this model? The total number of, so we can, for x and y, so here they did not say it positive and negative class. That's the difference. Generally for two class, we say them positive and negative class, and we directly say positive, false positive, true positive in that way. But here they named it like the multi-class thing that we did. In the lectures we did for multi-class classification also, right? Precision, recall, F1 and everything. So they followed the same terminology. What is the accuracy of this model? Total correct predictions. Total correct prediction is 14 plus 8. So 14 plus 8 upon total number of predictions is what? 30. So that will become 22 upon 30, which is 11 by 30. So option C was correct.
15,
and,
15.
Sorry, 11 by 15, yes. Which made option C correct and D incorrect. And now if you write precision of x, precision always depends on predicted values, not predicted values, okay? And recall always depends on actual values. So predicted will be what? What is the predicted x value? 16, out of which how many of them are correct? 14. So the precision of x is 7 by 8. And similarly the precision of y is, precision for y is total predicted is 14, and out of them 8 are correct. So it is 4 by 7, which is bigger. Obviously precision of x is bigger, and hence precision of x is greater than precision of y. Option B was also correct. Now for recall of x is what? Recall depends on actual values. So recall of x will be actually how many x's are there? 20. Out of them 14 are correct. So it will become 7 by 10. And similarly recall of y is what? Recall of y is 8 by 10. So 8 by 10 is higher. Recall of y is higher than x. So option A is incorrect. Correct options are B and C here, like the precision one and the accuracy one. Cool. So this was another question from machine learning. Now let's move to the next problem.
one more problem from Python, and again this was also from, like, we have discussed these type of problems whenever a function is returned as a value from another function, and it also involves lists. Keeping in mind that lists are mutable, so they have like exploited this concept, like 3 or 4 questions they've asked. This outer inner question. A function is given with name as outer and an empty list is defined in it. Another function is defined inside the scope of outer called inner. Which takes value as an input, as an argument, and it appends that to x, return x. That's it. So that's the working. That's what this inner does, and what the outer returns. Outer returns this function. So in Python, we can return a function from a function. Outer returns inner. Okay. Then two variables f1. Outer is assigned to f1, and again outer is assigned to f2. So since they are two different assignments, so the copy of this list won't be shared among f1 and f2. This was the catch. So if you remember this, we discussed this, that like even though the list is mutable, but if you're defining these two functions separately, they won't share x. They won't share x. And then 4 prints are added, f1 with value 10. What it will do? It will call this f1, which is this outer, with an argument. Outer is not expecting an argument. Inner is expecting an argument, but since outer is returning a function with the name as inner, which is expecting one argument, so this is a valid function call. This is a valid function call. It will trigger this inner with value 10, and it will append this to the copy which is shared for all the functions call that we will be making using this label f1. Okay. Again, print f1 20. This will return a list 10. Since we are calling the same function again with value 20, it will share f1 will share the copy of x. It will return 10, then append 20, and this 10 and 20, this list is returned from here, right? Then print f2 30. The third print statement, we are using a different function call. We are using f2, not f1. So this is it will create a new copy of x, which is an empty list. It is not related to f1. It will just return a list having a single element as 30. And there was one more print, f2, not f2, f1 with value 40. So this will extend this list. It will be 10, 20 and 40. So I guess there was an option among 4 that whether f1 and f2 will point to the same x. So that option was incorrect. f1 and f2 won't point to same x. Then there was option what it will print. It will the final one, it will print 10, 10, 20, 30 and 10, 20, 40. That's it. So the other three options B, C and D, I do not remember them precisely, but they were solvable if you have if you're getting these as the output. Okay. All right. Next problem.
Okay, next machine learning problem. So the easiest problem again after the A star problem, the second easiest problem from, but it's, the only thing that makes this problem difficult is it being MSQ. Okay, you have to think twice. So there was like column 1 and then column 2. Column 1 denoted task and the column 2 denoted algorithm. So which task can be done using which algorithm is what they were asking. So first task was clustering, and then classification, and then sampling, and then dimensionality reduction. And here the algorithms were K-medoids, Markov chain Monte Carlo, LDA, and naive Bayes. And there were 4 options given. But the only possible option here is, see, K-means or K-medoids is a clustering algorithm. MCMC is a sampling algorithm. LDA is a dimensionality reduction algorithm, and naive Bayes is a classification algorithm. So the only possible match was this one. Like whatever, probably the order might be different in exam for you, or like here also, like I might have given a different order, but this is the only possible and acceptable option which was correct in this case, for this question. Okay. Cool. So this was the next question. Again, I'll still call, like, if you guys have more probability or linear algebra questions, keep giving them, because from my side, like I gave all the probability and linear algebra problems which I remember. So if you have more problems, let us know. We will add them here. Cool. So let's move to the next problem. Then we will solve more ML problems.
There was a problem on maximum minima. I'm not sure whether this is the correct function that was given in the problem. If I remember it correctly, a function was given. Can you like validate it? Fx was x cube minus 3x square plus 2.
I think yes. I guess yes, this was the function.
And the range was given. Oh, a domain was given.
And the domain was given between
-1 and 3.
Minus
-1 open.
-1 open and 3 closed.
Yes. Right. This is x belongs to. This is the domain. So 3-degree polynomial function is given. And the options were regarding the maxima and minimum values that this function can attain, including some options like pointing towards the roots of this equation. The problem was easy, but the only catch was the initial value. This -1 is open and 3 is closed. So if you take this into consideration, you will mark it correctly. Okay, for that, the idea is simple. You find the critical points, calculate f dash x, 3x square minus 6x equated to 0. It will give you x as 0 and x as 2. Right. Then f double dash x, which is 6x, and you put these critical points in order to get for what values, like if f double dash x is positive, it's minima, if it's negative, it's maxima. For x is 2, and like we already know, like the shape of a 3-degree polynomial graph. it is like this. A is positive. This coefficient is positive. So for when x is approaching to infinity, f of x is positive. When x is reaching to minus infinity, a very large negative value, f of x becomes negative. So this is what the shape of this graph looks like. Right? Okay. Do you remember the options?
Yeah.
One option was whether x is equal to 1 is the root of this like equation or not.
So one
X
yeah.
is equal to 1 is the root, so that option was right.
And other option was
So it will pass from 1 comma 0. It will pass from 1 comma 0. It will maximize at 2.
And one
It
no
will-
the option was it has exactly one maxima,
It has exactly one maxima, it has exactly one minima,
and one
and
is a root.
two roots between
Minus
between
1 and 0.
minus 0.9 and 0.
Yeah, like yeah, something like that.
Mhm.
Yeah.
So that option, like, so for 3, if the value is 3, if x is 3, it is the maximum x that can be put in this function, which is the highest point in the domain. When x is 3, it's 27 minus 27 plus 2. It will be 2. It will be 2. So we won't draw the graph beyond this x, right? And 1 is the root, correct? At x is equal to 2, which is a critical point, f double dash x is positive, f double dash 2 is 12, which is greater than 0. So it will be a minima. It will be a minima. So we can calculate the value at 2. F of 2 is 8 minus 12 plus 2, which is minus 2. Which is minus 2. So at 2, it will be minus 2 here, and it is 0 over here. When x is 0, it is 2, so it is also going here. The shape is looking like this. It looks like this from 0 to 3, but like minus 1 and 0 is also there, so we can calculate what will be the value of f of x at minus 1. But like minus 1 is not included. F of minus 1, it will be a open bracket. F of minus 1 is minus 1 minus 3 plus 2, which is minus 4 plus 2 minus 2. At minus 1, it will be at minus 2, this point. Yeah, so the curve will look like this. Okay.
But there is a hole at minus 1.
A hole at minus 1. This is open. And this is closed. I think there was a trick in an option.
Yeah.
It was asking, it will attain maximum value
Exactly once.
exactly once, which is
Yeah.
incorrect. It is attaining maximum at 2 points. At x is equal to 0, which is the value is 2, and at x is equal to 3, both
Or maxima.
are maxima. That option was correct. And minimum value exactly at 1 point, correct.
Minimum was exactly at 1 point, and
Because this is
point-
open. Because this is open.
Mm.
If this was closed, in that case, minimum will also be attained at 2 places. And one option was
There
x
are-
is equal to 1 is the root.
Yeah, that is correct.
Is the root. Correct. And fourth option was
There are two roots
two
between.
roots between minus 0.9 to 0,
Yeah, this is incorrect.
which is the only one root. I think one also we need to check where exactly it is passing from
Yeah, we.
the x-axis.
Yeah, it looks.
But it
like
is not 2. But it is not 2. So this option is incorrect. Okay.
Cool. Next question, someone is asking in the chat, like the number of trainable parameters in a neural network. Sorry. So the question was, there are 30 layers, 30 input neurons. So in the input layer, in the input layer, there are 30 neurons. And there are 2 hidden layers given. Hidden layer 1 and hidden layer 2. Hidden layer 1 contains 4 neurons. Hidden layer 2 contains 3 neurons. All the ML problems were easy. You see, I'll repeat this again and again. This paper ML was really easy. Probability was slightly on trickier side. And there is one output neuron, one neuron in the output layer. And they said explicitly they said in the question that there are no biases. There are no biases. Okay. So it will be a like fully connected graph. It's a deep neural network. It's a fully connected neural network. So how many weights can we train? So the number of weights between these 2 layers will be 30 into 4. Between these layers will be 4 into 3. And between these 2 layers will be 3 into 1. So these are the total number of trainable parameters that we have in this model. So 120 plus 12 plus 3 is 135. So there are 135 trainable parameters in this model. 135 was the answer to this problem. Now there was another problem. This is on agglomerative clustering. So there were 5 points given. P1 was the point given as 2, 3, minus 1. P2 is given as 3, 1, 1. P3 is given as 5, minus 2, 3. P4 is given as 3, 3, 3. Or probably like these two were swapped. Yeah. Yeah, so these are the 4 points given, and we use Manhattan distance. And we want to find, and we are doing agglomerative clustering. Very easy problem. We are doing agglomerative clustering. The question was asking which 2 points will be merged first. In the first iteration, okay. So in the first iteration, we will merge the points which have the lowest distance. So we will calculate the Manhattan distance between every possible pair of points. So we will calculate between P1 and P2. How to calculate the Manhattan distance? Just subtract x and y, take the absolute value and add them. So 1 plus 0 plus 4, 5. P1 and P2, P1 and P2 is done. P1 and P3, 3 plus 5, 8 plus 4, 12. Similarly, P1 and P4 will be 1 plus 2, 3 plus 2, 5. Similarly, we will have P2 and P3. The distance between P2 and P3 is 2 plus 5, 7 plus 0, 7. Then P2 and P4, the distance will be 0 plus 2 plus 2, 4. And last, the distance between P3 and P4 will be 2 plus 3, 5 plus 2, 7. So the lowest possible distance is between points P2 and P4. And the answer was, there was an option called P2 and P4 will be merged. And that was the correct answer. Okay. Again, very simple problem. All the ML problems are really simple. Cool. Let's see some more problems. Then we will see more ML problems. Okay, I have more ML problems then. Let's see more, like question number 39 then. So in this question, they were saying we are using ridge regularization. And we are doing it using gradient descent. Like we are applying gradient descent, which means we are training neural network model. We are training some model. Basically, there is some loss function.
The loss function was also given to us, actually, I think in this question, yes. Yeah. So what the question was, the question was saying that the output is the predicted output. The predicted output of the model is W times X. And we use mean absolute loss function. We use mean absolute loss function. For one data point. So there was one data point also given. So the data point given was 1, 2, and the initial value of weights that was given was, so this is W transpose X in that case, yeah. So the initial value of weights that was given as -3, 4. And after one iteration, what will be the values of weights? Okay, no, they were not asking that. They were asking at this particular iteration, what was the regularized loss function, or the value of the loss function is what they were asking. So they were asking the value of loss function. So here you just need to remember the formula. So what is the loss function? The loss function is mean absolute loss. Mean absolute loss means the actual value of y minus the predicted value of y. This is the mean absolute loss, plus lambda times summation bi square, summation weight square, like the L2 norm square is what we will add in ridge regression. So this is the ridge regularization part, and this is the mean absolute error part. And the coefficient of ridge was given as 0.1 or 0.2, I think. 0.2. Essentially everything was given, and also the actual value of y was given as 3. So in that case, the mean absolute loss become y minus y predicted. Y predicted will be the dot product between these two vectors, which means -3 into 1 plus 4 into 2. Plus lambda is 0.2 times wi square, which means 3 square plus 4 square. So it will become 3 minus 8 plus 5, 3 minus 5, which is 2. So 2 plus 0.2 into 25, which is 2 plus 5, 7. So the value of loss function was 7 in this case. Any doubts? Okay, let's move to the next problem.
So this problem was from SQL. I do not remember the entire problem, but I can give you the crux. Yeah. So data set was given. Data set and salaries were given. First value was 5,000. Again 5,000. Then 10,000. 15,000. And 18,000. I think it's IDs and it's salary. Do you remember the exact query of this? ID and salary, in which a query was given,
Yeah,
which says something greater than equal to. Two subqueries were also given.
yeah.
And
So it was a very long query essentially.
And the first part of this subquery was, give me salaries which are
Greater
greater
than
than all other salaries.
the count
Count of salaries with
the count of this particular salary. How many salaries are there which are less than this particular salary? That count.
okay. The
So,
first was okay. Less, and in the second query was greater than.
Yeah. So how many salary counts are actually less than this particular one? So
We have to take one by one and then identify.
yeah. So it is the other way around. Otherwise, because I remember 5,000 was the correct one.
We're getting 3 records. The answer was like 3.
Yeah. So here like 5,000 will be less than all of them. So yeah, correct. Yeah, this is the correct. Yeah.
Okay. So this was the query in which we need to give the first subquery was count all the salaries which are greater than which are less than, for the first time this one, then this one, then this one. We need to keep on doing this for every row or every salary. And the second subquery of this query was give me the count of all the salaries which are greater than this current salary. Okay, one by one we'll be picking all the salaries and then identify. So for the first case it was 5,000. So it's just we need to check whether 5,000. We need to check the count, how many records are present in this table which is having a salary less than the first salary that we have chosen. Okay, so 5,000 is not less than, again this is also not less than, no. So this is, none of them are less than 5,000. So for this comparison holds 0 for 5,000, right? Then is this 5,000 greater than equal to, the second subquery was count all the salaries which are greater than this 5,000. 10,000, 15,000, 18,000. So yes, 3. So if 0 is greater than equal to 3, then only this record will be considered in the final output, otherwise not. So we will check this for all the salaries. So the first is incorrect, it won't get into the final output. The second row, again 5,000. The metric remains the same, 0 greater than equal to 3. It also won't be there. 10,000. Count the salaries for which 10,000 is less. So it's only for 2, 15 and 18. So 2 greater than equal to, count the salaries for which 10,000 is greater than. 10,000 is less, it will be 5,000 and 5,000. Again, count will be 2 and this is also 2, so it will be there. So 10,000 will be present in the output. Then for 15,000, if someone knows the exact query, you can tell me in the chat, I'll put it here, but this was the overall idea behind this. Whether 15,000 is less than how many salaries? So only one. Is it greater than equal to? 15,000 is greater than how many salaries? Answer is 3. Greater than 5,000, 5,000 and 10,000. I think it was like this only. First was and finally we will check for 18,000 as well. If this adds up with 3, otherwise the query will be other way around. 18,000 is lesser than none. Is it greater than equal to? And 18,000 is greater than 1, 2, 3, 4. All of them. No, no. Are you sure the first one was lesser than? Are you sure the first one was lesser than?
I'm not sure, but the count of so 5,000 is less than these 3. So here the count becomes 3, right? Here you are doing it the other way around, I think. I'm saying the count of the salary in A, which means the first one is less than how many? So this becomes 3 and this 5,000 is greater than none of them. So 3 is greater than equal to 0 is correct. Now again for B also 5,000 it will be the same. So 3 and 0 again will be correct. And for 10,000 it is greater than 2 of them. And it is less than also with 2 of them. So this is also correct. And for these 2 it is incorrect. And hence the first P1, P2, P3 will come in the answer.
Okay.
And
it was a bit if you crack the query, then question becomes easier.
yeah, the crux is this, you need to figure out what you need to calculate here in the less than and greater than. But the answer was 3, P1, P2 and P3 will come in the answer. So now we are going in that gray area, now we will give you some of the questions which will just remember the answers and just glimpses. So we will just quickly give you the answers to 5 to 10 problems which we know that way, okay? And so that so as to make this set even more better.
There was one more query from DB. But like it was a complex one, I forgot.
There was one relational algebra question, very long, joins.
How many rows will present in the final natural join of that algebra?
Right, and there
Two tables were given.
I don't remember the answer, but yeah, but it was a very long natural join question. Okay,
Do you have something?
I have a few questions, but I still okay. So there was one. I'll just quickly give
41.
you. I'll just quickly give you the answers to a few questions. I think yeah, like once the paper comes, we can discuss the solutions again in detail. So one was a random variable x is an exponential random variable with parameter lambda as lambda was not given. It is a classic question, the exact same question we have solved in class, the exact same question I have given in at least 2 tests. This problem is on the property of exponential random variable being memoryless. It is memoryless, right? So exponential random variable probability of x being greater than 5 was 0.35, and we had to calculate probability of x being greater than 10 given that x is greater than 5. So it will be nothing but probability of x being greater than 5, because exponential random variable is a memoryless random variable. So probability of x is greater than s plus t given that x is greater than t is probability of x being greater than s directly, and this is given as 0.35, so the answer will become 0.35. This was one question. Okay. Another question from algorithms, which if you remember, there was one question in which there was a directed graph G, and there were some rules given that it might contain cycle, and it might not be strongly connected. So essentially there are no strict rules. They might not be strictly connected, and it is a directed graph. And we create another graph GR where we reverse all the edges. So here the correct option was, if there is a path from U to V in G, in the DFS of G, then there will be a path from V to U in GR. If you use BFS or DFS, it doesn't matter actually, but in the option they said if there is a path while using DFS on G from U to V, there will be a path from V to U in GR. Yes, because we reversed all the edges. So if there is a path from a vertex U to a vertex V in the initial graph G, in the reverse graph there will be a path from V to U, and all other options were incorrect in this case. All the other options had U to V and U to V only or something like that. So the only correct option was this one here. The only catch is they said DFS and BFS here, but that doesn't matter. They both are complete search algorithms, right? If the graph is finite, they both are complete search algorithm, and hence, yes, if there is a path from U to V in using DFS and G, there will be a path from V to U on GR using BFS. Okay, now, and there was another AI problem where it was a very complex problem. Again, we don't remember the options, but we remember the answer. But I remember the option. Like it said that a creative person is successful if
It's from logic.
If they are disciplined, yes. If they are disciplined, else not. And there were 3 logical statements given, only one was correct. The one statement was, here it was a very tricky problem, okay? They are saying creative person is successful if disciplined, else not. So the entire condition, this entire condition was based only on creative person. If the person is creative, then only we care. If the person is not creative, we don't know. Anything can happen. It might be, he might be successful, he might not be successful, based on discipline or not, that is not given. So the correct option here was, if the person is creative, then only we care. So if a person is creative, that implies, then in that case, successful and disciplined are interlocked, which means successful implies disciplined and disciplined implies successful. So there was one option. I think this was the second So it was like something like there was one predicate P1 given, then another predicate P2, which was this, and P3 was another predicate, and these two were incorrect. So the correct option was P2 only. Something like this. Okay. And I think that's that. There is another ML problem where we had to optimize. There was question number 44. There was another ML problem where fx was wx. Initial value of w was given as 10. Initial value of x was given as 10, and learning rate was given as 0.1. So after one round of iteration, what will be the new value of w? So the new value of w will become old value of w minus learning rate times the gradient of loss function with respect to w. So the loss function that we were optimizing was w into x in this case, and hence it will become the old value of w is 10 minus 0.1 times the gradient of w with loss function with respect to w is x only. So it will become 10 minus 0.1 into 10, which is 10 minus 1, which is 9. So the answer was 9 here. Okay. So do you have any more problems?
I don't like. I remember vaguely, but not like precisely.
We can briefly discuss, but yeah, like I think if you guys remember any more problems, you can write them in chat. We will be happy to discuss. Or at least we can tell you the answer as per our knowledge or our remembrance. They might or might not be correct. But yeah, like out of 65 questions, 43 we remembered. Like that's a good number, I feel. There were a lot of
binary search problem, man.
Yeah, the binary search problem.
The answer was 10 for that.
So it
was easy. Like
there are 1000 points, and we are doing binary search.
Right.
And how many maximum possible searches, comparisons we will do.
It was given that the binary search is recursive, but it won't matter.
Yeah, recursive won't matter, and it was given that every comparison gives you actually less than, greater than, and equal both. Like one comparison can give you everything.
Yes.
So how many comparisons will you do? You will have to do 10 comparisons, like log 1000
base 10 seal base 2
base 2 seals. So that is 10 comparisons.
Like every comparison is breaking your search space into two halves, and only one you are choosing.
Correct. Any other problems? So we still don't remember 20 more problems, but yeah, these are the correct answers to 45 problems, and I think this is sufficient for this lecture. Once the answer key and the responses come, we can discuss all the problems again. We will have a live
detailed solution. Yeah, we can.
The detailed solution, or we will post a recorded session with the solution to all the 65 problems once the answer key and the responses arrive. Even if you vaguely remember any problem, just even one word, you can tell us. Otherwise, we'll wrap the session then. Okay, I think someone sentence X is said to entail Y when X is true. Y would also be true. Which of the following is? Yeah, there was a problem like this. X entails Y if X is true, and Y would also be true. Yes. So if Y, then X is correct here, right? Or it was MSQ. I don't remember the options correctly. Insertion in bubble sort 2 mark MSQ. Yeah.
There was a number of comparisons in insert, but like, do you remember the options?
Yeah,
number of comparisons in
need
bubble sort and insertion sort.
Yeah. So that was
one option was there, like they will have at least one comparison.
Yeah, so
that was correct.
So there was one option is like they will have at least one comparison with some element which does not, which doesn't matter, because which is already small, with at least one small element.
One option, remember, the comparisons in bubble sort would be greater than insertion sort.
Yes, that was correct.
That was
Because
correct.
I think it was 10 and 4 or 10 and 5.
Something like that.
So yeah, that option was also correct. And yeah.
Other option I like. I'm not sure.
And another problem is like quick sort में first pivot करके पूछा था वो हमने discuss कर लिया
Oh,
actually.
okay.
Sir, yeah,
Then
Srinath
that's
sir
it.
discussed it.
That was the problem on randomized quicksort.
And the answer was like the big expression.
Yes.
Yeah.
You break it at any k and you take the time complexity of the left chunk of the.
Right. Roll up, drill down. Is that done? The answer was roll up. We are not sure about the
is it
answer
exactly
also.
roll up or
Yeah,
drill
we don't
down?
because we don't remember the question exactly, but I think we think that the answer is roll up based on whatever question we remember. There were options like roll up, drill down, slice and dice. So now the exact
Slice is eliminated. Slice
and dice cannot happen.
Ha.
The confusion is between roll up and drill down. But we strongly feel the answer is roll up here.
Yeah, but like.
So I'll add a question mark here. Okay. So after question number 45, ignore the verdicts. Like we are just giving our judgment. Binary search with 1000 distinct integers. The answer is 10. We already discussed. Insertion sort on P performs only one swap. Yeah, you gave the options. Insertion sort on P performs only one swap. H1 is 10, H2 is 4. Yeah, so H1 is 10 and H2 was 5, I think, and that made this option incorrect, as far as I remember. I'm not like pure sure because we need to know the array for that. Inserting, deleting records. Yeah, that's a very, very, very naive question. Question number 48. Yeah, very like. Did you discuss that?
Which one?
So if there was a table S and there was a table R, and here one key was referring key here. So which of the operations?
No, there were two options violating the foreign key constraint.
Yeah. So very basic. Very easy
it's
question.
a very easy question. It was like S is there, and there was a primary key, and like some other attribute, and there was another relation R. Again, it's primary key attribute. It's P1, P2, and a foreign key attribute, which is referring to P1, right? So the options were which operation will violate the foreign key constraint. So
the answer was either you insert in S or you delete from R. That too won't violate.
Yes.
If you add anything in S, that won't violate anything.
Or
and
you
if you delete from R, that won't.
That won't violate. The other remaining options were the correct ones. Either you add something in R, it might violate, because if that key which you are adding not present in S, it will violate. Or if you are deleting something from S, that will also violate, because you might have to cascade the deletion in R.
Yeah, correct. And the country to state problem already Srinivas sir discussed. That is the 4 to the power 3 question. We discussed it in detail. And the one question GG09, you like, thanks for reminding me. There was one very long question, very long complex expressions. But yeah, like it was like something like summation I is equal to 1 to 1000 xi minus xj, and summation j is equal to this whole square was given. 1 by 99 of it was
1
given.
by 2000 is equal to 99.
Yeah, I think something like this was given. And we need to calculate 1 by 99 of summation I is equal to 1 to 1000 xi minus x bar whole square. So I don't remember the exact problem, but the answer came out to be 20. And in exam I used a trick to do it. You might apply similar tricks. What I did was take a general vector as x, 0, 0, all zeros. So which means I took the vector essentially as some x, 0, 0 and 0. So what should be the value of x which satisfies this equation? So that x came out to be square root of 2000. And based on this vector I calculated this, which came out to be 20. Okay, so the answer was 20 for this question. And once the question comes, we will get the formal solution as well. Like this is the trick solution which I am telling you, but yeah, the formal solution we will discuss once the question comes. We didn't have enough time in exam. All humans are mortal question, good. So there was a question, all humans are mortal. For all x is human implies is mortal, okay. For all x, classmate xy. So here human mortal option is correct. And classmate option is also correct. Because it was just saying classmate of xy implies classmate of yx. Each king is a person is for all x, this was incorrect. And for all x, if x likes an ice cream, there exists an x likes an ice cream was also correct. If for all x, x likes ice cream, then they will exist. If you are saying, if the options you are saying are the same, then this is the answer, but it might be possible that the options are different. Okay, here I don't remember the options. Country to state is drilled down in that 47th question. Okay. Okay, then yeah, if more people are saying that, it might be drilled down. Okay. We still don't remember. Like I don't think it was drilled down operation. We think it was roll up. But yeah, it might be drilled down as well. This is like yeah. Let the question paper come. But yeah, is there any other problem you want us to discuss? We are now at question number 50. GC less than HC, I didn't get time to finish that problem. I don't even remember the data. It was like some normal and T distributions, right? And there was another on chi-square distribution. And we need the questions, complete questions to answer those. The PDF, CDF one, yes. I'll not be like... But I think in that question, the CDF at 0 were equal and f of 2 was less than g of 2, something like that. Okay, don't get confused. Like let's not get confused. Like till here everything is fine. Like let's just like I think this is enough, and let's stop the session here. If you remember some question completely, you can write on the Discord server. We'll answer there. But all in all, these are the solutions to the questions which we remember from today's paper. And we hope that your paper went well, and after the exam, like the responses arrive and the answer key arrives, we will have detailed discussions, and we will you can like discuss with us what are your future options. We will do career counseling related to your GATE exam. If your exam didn't go well, what to do, if it did go well, what to do. In the next coming 10 to 15 days, 1 month, we will discuss all these things in a lot of live videos and recorded videos. So don't worry, we will be with you. And yes, like good, like the paper is over. Let's discuss again once the answer key comes.
Alright guys, thanks for joining us for the discussion. We'll meet in the next like.
Thanks, bye.
Okay.